Hello. Right, so I have written out some of this geometry so that it's a little bit quicker. And before I did that, I just changed everything back to 0.5 on the voxel size and to 0.1 on the remesh. And the reason is I actually want to use this mesh later on to generate the hexagons. So I've changed my mind slightly on the best approach here, and basically at some point down the line I need to branch off here and generate our actual rendering mesh. So what we're doing here with the propagation is just setting up masks to use for the effect later on, and the masks that we generate here we'll just use as a basis for the rest of the effects here. So my point is that it's actually more important to generate a usable mesh at the start, because the hexagons and everything else will be based on this geometry, and then find another way to deal with the timing of the propagation that doesn't rely on the density of the mesh. So I've written that out, moving it back to the origin or the rest position, and then I have this locked starter and our propagation solver here. So at the moment this solver is set to 1 on the attribute transfer, 0.1, and I've channel referenced that on the other transfer as well. So if I play this through, it's quite fast. It has to be somewhere around 0.1 at this resolution of geometry for the propagation to actually work. So for now, let's see if we can adjust this timing to work through the shot camera. And to do that, I need to move it back to the anim P. So I'll say here at P equals anim P. So now we can start to adjust this in the shot. So for starters, I don't actually want the propagation to start at frame 1. As I said before, I want a few frames at least where we get to see something invisible moving against the background environment. So let's go for like a full second. Let's go for 24. So all I need to do is set my solver to start at frame 24. And so if we go now before 24, there's no geometry at all. But it doesn't matter. As I said, we're going to be taking this geometry to make the actual effects. And this propagation will just be the mask that we use to drive all of that stuff. So here we'll have 24 frames of the drone coming into shot, being slightly invisible, and then from frame 24 we'll start to see it unravel. And the timing here, I think it would be best if it took long enough that it only just finished revealing itself around here, so just before it activates. So we want it to take a little bit longer. So to do that, I just need to adjust our attribute transfer down. Try 0.5. Okay, so now we're too low. So I tried to half the speed, but the mesh is too low resolution for the propagation to work. So a new plan, we're going to scatter some points here. Once again, we don't need to render this, so we're just generating masks. I'm free to do whatever I want. And if we just scatter loads of points, that should be fine, and it should give us an infinite amount of range with the attribute transfer there to make sure the propagation's working. So this is at 0.05. We're just propagating along a point cloud now with very tightly packed points, and you can see we've got plenty of space there for the transfer to work. And in terms of timing, that's not bad actually. So I'll do a quick flip book. And then there's a small beat there in between where it finishes. Then there's a little pause, and then the drone activates with its animation. So that actually feels pretty good. The propagation is slow, and it's filling in the shot nicely here between the beginning and the end, with just a little pause here and a pause here before it activates. So let's go with that. And here we can look at the shape of the propagation. You can see it's actually quite smooth. So we've got a pretty perfect looking shape. So let's try and add some noise to that. And there's a few ways to do this. I'm going to use the simplest way. And that's, we'll take our mesh and we'll noise it up here. And I actually use this attribute noise SOP quite a lot more than I thought. I used to just make my own noise every time in a VOP, but I have found myself using this one. Right, and the problem is our starting points are locked, but because I reverted back to when I deleted that, it shouldn't actually matter. Let me unlock that and just check. So that looks fine. So basically, because I changed my mind and we're really defining our geometry up here, I'm pretty free to delete points and be sure they're not going to change. Once again, you could have done a more procedural workflow for this just to make sure. Right, so the idea here is I'm just going to add some noise to P. Let's go with centered, sparse, doesn't really matter. We just want to mess this up. So we're just going to mess that geometry up, and then our scattered mesh looks like that. And now if we propagate, we're propagating along a noised P. And if I move this back to anim P here, you can see we're getting some variation and it's a lot less perfect. And we can probably go quite extreme with this. And it's running pretty quick, so lots of room for experimenting here as well. So there's a very noisy propagation there. Like, we don't need anything so organic feeling as this. I mean, if you're doing a more magical style, then you'd want pretty noisy so it feels quite organic. In this case, we're doing sci-fi, so it doesn't need to be over the top noisy. That's probably too much. So I'm just going to stick with around 2 here. and we'll work with that for now. So last thing to check after we've noised up the propagation is just to check that the timing's not been affected too much. So the start time is obviously preset. And it looks like this noised up area is struggling to finish in time. So here I can just go back in and increase our speed a bit. Yep, so that does it. So there's a nice noisy propagating effect that's pretty good timing wise, I think. So where do we take this from here? I can make this this mask allow us with some more control basically. We're not going to start just yet with the actual geometry updates to this. So let's try some, well, for starters, if I just time shift this, and let's say go backwards in time by 1 frame, you can see here I'm getting a 1 frame offset there. So if I delete everything except white, so we'll just keep the white ones, and I'm going to color them black. Then I can transfer that black color onto the original one. So you see I'll get that edge. So just by doing that, we get a nice leading edge, which I can use to either boost up some of the effects that we'll do later on, or maybe use this as a source for some particles, which actually I'm going to do that now. So let's just keep just the white ones again. I mean, that looks pretty cool. And then put this in a pop net, just so we can generate a nice edge. You could also, if you're more technical, you could use some attributes in the solver to generate your own custom edge attribute. I'm not too good at trying to figure out that kind of stuff. Being much more of an artist, I'm just used to throwing down nodes in Houdini that work for me, so PopNet should work just fine. So we want to say all points, first context. I'll set the life here to 1. And that's all fine. So now we're just emitting points that get left behind, and then they eventually die. So that gives us a nice width to our mask. And also I can have a fade. So let's say if we put down our angle, I can say color, make it a ramp called fade based on age. So now we've got a nice little fall off there for our mask. So that's not bad for a small little addition there. Let me save. And then we need to check that we can transform this back into the animation position. Okay, so we have a slight problem. So I'm just viewing my animated cache here, and this is our points being moved back to anim_p. So I can see what's happening here. The source has the correct position, but the particle being left behind doesn't have anim_p or the correct anim_p, or basically it has it, but it doesn't know to keep that position from its source. So we're just ending up with particles that get left behind. So let me double check. So these particles are getting it, but obviously it just gets it from its source point. So as soon as it emits a point, it gets that value, and that value is never changing. And the whole point is our anim_p is changing over time. So I can't just say p equals anim_p. I need to match a point to the original point cloud. So let's say this one. This is our full point cloud that has non-changing point numbers. So if I generate an ID attribute from those point numbers and don't generate an ID from the pop, then I can compare the sim. Let's do it here. I can compare the popnet with the non-point number changing point cloud, and we'll just find the same ID attribute and match the anim_p attribute. So just to show what I mean, we have this, and it's a completely stable point cloud, so we don't have point numbers changing. So if I generate an ID integer and I use the point number, and we have our ID there, and our ID is not changing over time. And now if I go into the popnet and I don't add ID attributes, then each one of those points that's left behind has the same ID as the point that spawned it. So we can just keep comparing ID attributes from here. So when that point has a particular ID, then a point that's been emitted off of it has the same ID. It should take the same anim_p. So here's our messed up sim, and instead of doing that, I think there's a preset here, fetch second input attribute by ID. So we just need this section here, and we're making a new attribute called match point, find attribute value from the second input, so that's 1, point ID by ID. So it's already finding our ID attribute, and then the position of the particles will be not p but anim_p. And that didn't work. Oh, I need to use I need to use the point cloud that I've generated the ID on. So here's the ID attribute. So that's working. No, it's not. So what have I done wrong? That looks fine. I need to recook the sim since I removed the ID. There we go. And that's working. So yeah, a little bit of a roundabout thing to have to do there. I can't just emit points on our static geometry at rest position and then expect them to be able to follow along with my original NMP attribute. So all I had to do was generate an ID, keep that ID through the simulation, and then use that to match my particles to points on the original point cloud and use the NMP. And that gives us our particle-based point cloud with the propagation and a fade off from the leading edge to the back. So I think that's pretty good. That's probably a good place to stop for now. And I think we're really nearly ready to start trying this out on our hexagon mesh. So I'll save that for the next video, and I'll see you then.